Example 6. Find all solutions of sine x minus cosine x equals 1 on the interval 0 to 2 pi. Now, here, unfortunately, you can look at and try all kinds of different plans. We could switch to sines and cosines. We could try all these different things. But when it comes down to it, this one is just not, we're going to have a hard time coming up with a good solution. So here it says solve by squaring. It kind of gives it away what we need to do. But if you're coming, this is kind of looking like a Pythagorean theorem, except for notice that it should be sine squared plus cosine squared equals 1. That's not what we have. So here's what we're going to do. We're going to square this real quick. But I think it's easier if you use the 1 as well. So I'm actually going to move this across the cosine. Since it's negative, I'm going to move that one over. And so I will have that sine x equals 1 plus cosine x. And now what I'm going to do is square both sides. So when I square both sides, you need to do so with a parenthesis, which means I'm going to have to FOIL this end over here. Okay? So when I FOIL, this is easy. This becomes sine squared x. When I FOIL, do not forget that what you have to do is have 1 plus cosine x times 1 plus cosine x. And so when we FOIL that, we get 1 times 1, which is going to be just that 1. And then we would have 1 plus cosine, so we have 1. And then 1 times cosine, I'm sorry, which is cosine x. But then I do this here and have another cosine x. And then finally, cosine times cosine is cos squared x. And so when I simplify these terms, I have 1 plus, these are 2 cosines, 2 cosine x plus cosine squared x. So now I have all of this. Now, to simplify this problem, I have the sine x over here. I have 1 plus cosine squared. Now, first you could check, is that the Pythagorean identity? 1 plus cosine squared x? And you'd find out it's not. Unfortunately, 1 plus, if cosine was over here, it would be 1 minus cosine squared. But what I can do is change out that sine squared. So sine squared, right up here, the Pythagorean identity is that sine squared theta plus cosine squared theta equals 1. That means that sine squared by itself, sine squared theta, is equal to 1 minus cosine squared theta. So that's what I'm going to substitute here. So I'm going to do the Pythagorean and say that sine squared is going to become 1 minus cosine squared x. And now I'm going to combine my like terms. So I'm going to subtract 1 here. So if I do that on the left, I got to do it on the right. And I'm going to add cosine squared x here. And so I need to add cosine squared x there. I do that. These go away. This goes away. That goes away. And I'm left with 0 equals 2 cosine x plus 2 cosine squared x. Now, just kind of like the example 5, I'm going to do GCF. Factoring greatest common factor, they both have a 2. So I'm going to factor out the 2, and they also both have a cosine. So if I divide that out, I'm left with 1. 2 cosine x divided by 2 cosine x is 1, plus the cosine squared divided by 2 cosine would be just cosine x. And so now I have zero product property. And so from zero product property, that means I'm multiplying and I have a product of 0. The only way that can happen is that one of these two things has to equal 0. So either 0 equals 2 cosine x, or 0 would equal 1 plus cosine x. We'll solve this real quick. Here I would divide by 2. And I get that 0 has to equal cosine x. And over here, I would subtract the 1, which means that negative 1 equals cosine x. Okay, now let's use the unit circle. Come over here, unit circle. Put it on here. Let's do color. This unit circle. And which means if this is a unit circle, that this point right there is 1, 0. This one is 0, 1. This is my y-axis. This is my x-axis. Okay, we want cosine, my x's, remember cosine is x, to equal 0. Well, x equals 0 up here and down here at 0, -1. So it equals 0 at 2 spots. It equals 0 when we have pi over 2 and 3 pi over 2. So here, x would equal 0, or cosine x would equal 0 when x equals pi over 2 or 3 pi over 2. And then on this one, we want cosine to be -1. When is cosine -1? Well, that would be over here, because again, that's x, and this would be x going left 1 unit, -1, 0. And that value is pi. So this would be when x equals pi. And so these should be our answers here. Should have 3 of them. And the best way to check to make sure we did this correct is we're just going to use the graph, because the graph won't lie to us. So go to new document. I don't want to save. I want to go to graph. I want to put the left on one equation, the left side, so sine x minus cosine x. And that's going to equal the right side, which is 1. And again, the interval is 0 to 2 pi. I'm going to change this. Just so I can see the 0, I'm going to do -0.2, just so I can see a little bit. Press enter. And over here, I only want to go to 2 pi. 2 pi. So put 2 pi, press enter, and now I have that correctly listed. And it seems that we have, let's analyze graph, intersection. I see I have an answer here, 1.57, and menu, analyze graph, intersection, here, 3.14, which is pi. Now, where is 3 pi over 2? Did we make a mistake on that one? So we said, let's check our work, because the graph is not showing us that one. So as I'm checking it over here, this would be right. So this must just be an extraneous answer. So I'm going to go back and write this in yellow, because that's what I usually do for extraneous. So yellow, here, this one. This answer here is extraneous. And if it's extraneous, that means it is not a part of our normal solution. So I'd actually need to change this circle. Let me delete that one out of here. Delete. And I'm going to do this again. And this time I'm only going to circle that part. Let me try that shape again. This would be our answer. This is extraneous according to the calculator. So that's where the calculator really comes in handy. Obviously you know work. That's handy. But additionally, and to that is that it will not include any extraneous answer. So this would be our correct answer here.